Good morning all. Today we will briefly discuss about image enhancement. In this discussion we will discuss about what is image enhancement, what are its objective. We will also discuss about the different image enhancement technique like linear transformation, non-linear transformation and piecewise linear transformation. So let us begin this discussion. First, what is image enhancement? Image enhancement is a digital image processing technique usually preferred in order to improve the quality of the image for a better human perception, for a better human interpretation. In our day-to-day life, several factors such as poor illumination of the light, noise present in our electronic devices, atmospheric disturbance such as cloudy condition, inadequate sampling frequency, and motion effect causes degradation in image quality during image acquisition as well as during image processing. Basically, there are two major objectives of image enhancement. First, to improve the quality of the image. In order to understand this, let us take this example. This is my input image A and this is its histogram. By looking at the histogram of the input image A, we can easily say it's a low dynamic range histogram. So it's a low quality image, and in order to improve the quality of the image A, on this image A we have performed the histogram equalization, and this is its corresponding output histogram. Since the histogram of the output image it is wider, and hence we obtained a high quality image output from this low quality input image A. This project work I made it in MATLAB. The next objective of image enhancement it is to suppress the noise. In order to understand this, let us take this example. This is my input image A. In this input image A, in order to make this input image A noisy, I have added the salt and pepper noise in it, and in order to remove the salt and pepper noise from this noisy image, I have applied the median filter, and as a result I obtain an image output which is free from salt and pepper noise. This is the example 1, and here I have used a grayscale image. In example 2, I have used a RGB color image. So in RGB color image, first I added the salt and pepper noise, and in order to remove the salt and pepper noise on this noisy image, I have applied the median filter, and as a result I obtain an output image which is free from salt and pepper noise. So this project work I also made it in MATLAB. Next, the classification of the image enhancement technique. So basically, image enhancement techniques are broadly classified into two domains, a spatial domain and frequency domain. In spatial domain, we assume the digital image it is made up of number of pixels. A digital image it consists of pixels, and each pixel has some intensity value, and in spatial domain we will directly work on this pixel intensity values. Whereas in frequency domain we assume an image it consists of some low frequency component such as the smooth region, and it consists of some high frequency component such as the edges. So in frequency domain we assume a image it consists of some low frequency components such as the smooth region, and it consists of some high frequency components such as edges. In frequency domain, the digital image which is originally in the spatial domain First we need to convert it into frequency domain. In frequency domain, we perform certain operations, and as a result we obtain and as a result we get some frequency domain output. And finally we back convert it from frequency domain back into spatial domain. Which is nothing but our final output image. So in frequency domain, digital image which is originally in the spatial domain, it is first converted into frequency domain by using this transformation that is called as the Fourier transformation. In frequency domain, we perform our operation and as a result we obtain our frequency domain output. Now from frequency domain, we back convert it into spatial domain by using this conversion that is called as inverse Fourier transformation. And as a result we got our final output. Image enhancement techniques based on frequency domain we will discuss in our upcoming lectures. In this lecture we will discuss about the spatial domain. In spatial domain, again the image enhancement techniques are further classified into two subcategories. One it is called as the intensity transformation, another one is called as the spatial filtering. So let us discuss both of these one by one. First we will discuss about the intensity transformation. In intensity transformation we will consider only the particular pixel P. We did not consider its 8 neighborhood pixel, we did not consider its neighborhood pixel. We will consider only this pixel P, and on this pixel P we will perform our image enhancement, and as a result we will obtain our enhanced image output. So in this, so the same thing you can understand in this figure. In intensity transformation we will consider a particular pixel P, and on this pixel P we perform our image enhancement techniques, and as a result we will obtain our enhanced image output. Next one is spatial filtering. In spatial filtering we have to consider the pixel P as well as its 8 neighborhood pixel. We have to consider the pixel P as well as its neighborhood pixels. And in spatial filtering we have to use mask in order to perform spatial filtering. In order to perform the spatial filtering operation we have to use some mask. The center of this mask we will place at the pixel P, and we have to perform the spatial filtering operation, and as a result we will obtain an enhanced image output. The same thing you can understand in this figure also. This is the pixel P. At pixel P we have to place the center of this mask, and we have to perform our spatial filtering operation, and as a result we will obtain our enhanced image output. Since in spatial filtering we use mask, this operation it is otherwise also known as mask processing operation. Whereas in intensity transformation we have to consider only this particular pixel P. In intensity transformation we have to consider only this pixel P. We did not consider its neighborhood pixel, and hence this intensity transformation it is otherwise also known as point operation. So contrast stretching, image thresholding, image negation, these are the examples of intensity transformation. Since in contrast stretching, image thresholding and image negation we will consider only the particular pixel P. We did not consider its neighborhood pixel, we did not consider its 8 neighborhood pixel, and hence contrast stretching, image thresholding, image negation, these are the example of intensity transformation. Whereas in case of image smoothing, image sharpening and image averaging, we have to consider the pixel P as well as its 8 neighborhood pixel. We have to consider the pixel P as well as its neighborhood pixel, and hence image smoothing, image sharpening and image averaging. These are the example of spatial filtering. So in this slide, we will briefly discuss about the various image enhancement techniques based on intensity transformation. Image enhancement techniques based on spatial filtering, we will discuss it in our upcoming lectures. So in intensity transformation, the general expression for intensity transformation, it is S equals to TR, where R represent the input image pixel intensity level, S represent the output image pixel intensity level, and T represent the transform operator. These are the various intensity transformation based image enhancement techniques. In linear transformation, we have to study the image negative and image identity. In nonlinear transformation, we have to study the logarithmic transformation and power law transformation. And in piecewise linear transformation, we have to study the contrast stretching, intensity level slicing and bit plane slicing. So in our upcoming lecture, we will discuss all of these methods in details. Today I am going to stop here. If you have any suggestion, if you have any query, you can write in the comment section or you can write email to me. Till then, happy learning, have a good day and thank you all.